Hello, hello. I hope this thing's working. Hope you guys can hear me. Hello. Seems to be a little slow, I think, but looks good. Looks like we have stuff functional. All right, great. Welcome, everybody. Good morning, good evening, good afternoon. Welcome to the stream. Thank you for being here. I think we can get started. Sounds like stuff is in place. All right, good. Hello, hello. Welcome. So I'm Gaurang. I am a second year student right now at UBC Okanagan, studying ComSci, and I will be hosting today's TensorFlow and machine learning workshop with all of you. So welcome once again. And this will also be recorded. So yeah, Windows 11 indeed. So welcome to also to everyone who's watching the recording later. Now. I'm currently not in Canada, sadly, because of COVID. I'm talking to you guys from Dubai. So, but I hope everything's going well there. I hope you're all safe, and I hope college is also going well for everybody. So I'll just sort of brief over what's the plan for the day, right? It actually was, yeah, absolutely. But I don't want to keep this stream too long and too boring. Not multiple hours long, 3-4 hour long kind of thing. About an hour and a half at most. And the plan essentially is to go over sort of the links you see in front of yourselves, some resources, some things like that, as well as something really special from OpenAI that I mentioned before. So this is the Codex private beta. You had to sign up a long time ago. It takes a while to get into it. I was lucky enough to get in, and today I plan to take you guys to through this whole process of what essentially you can do with some very powerful frameworks and some brilliant people behind it. So the plan is to we'll have some fun with OpenAI Codex as well, and alongside that we'll be talking about normal resources around with machine learning. So we sort of skim over a few pretty interesting things, right? This here is a playground where I can help you guys visualize what happens when you train a model and go over that, and sort of brush over some of these things that I mentioned before. And lastly, towards the end of it is when we'll get properly technical. We'll go through some code. So we'll start off here. So by the way, this platform is called Google Colab. Brilliant platform, and I'll explain further in detail later. But the plan is to sort of take you guys through almost an introduction to some simple stuff within Python, within machine learning. And this is a pre-built sort of beginner quick start by TensorFlow. So I'll start off with something simple like this, and then eventually we'll move on to something much more complicated but much more fun. The meme, like the meme distinguisher. So I built this model a while ago to sort of get sort of more familiar with Keras and the libraries, and I thought I'll take you guys with me to sort of talk over and go over what's happening here. So I have shared all this stuff with you. So if you're interested, if you want to have a look at the code yourself, you can go back and hop on Discord. I sent the links, so please feel free to hop on here, try it out yourself, mess with things. And the best part about this platform that I'm on, right, it's on my browser, is that it's actually not taking any resources from my computer. So my computer is just chilling there, streaming, of course, but it's not really what's going to be training or testing or doing all that sort. So I can train my entire model here and look at some pictures to sort of visualize stuff for all of you guys. We'll go through all this in more detail eventually, some graphs and everything. And these are actual pictures. This is the memes from Doom and Animal Crossing, and we'll be using them to essentially build a very simple classification model, right? A fairly common convolutional neural network, right? That's the plan. Yeah, so I hope this is it's fun and you guys take away something from this. If you have any questions, put them in the chat, and feel free to also reach out to me or anybody from our Discord server if you have any questions or concerns or even feedback. I'd love to hear how we can improve these things. This being the first one, so welcome once again, and thank you for being here. So yeah, I think we can get started. So first thing that I kind of wanted to touch base on was what exactly is going on within a model, right? We see these terms being thrown around with machine learning, with AI, and all that sort, but it never really is clear of what's going on, right? So put simply, it's just really smartly done stats and maths, right? It's just done very. It's able to make use of your computer's resources extremely well, right? So this right here is a GIF I found on the internet while, again, just trying stuff out. And it explains it extremely well, where you see these two are layers, right? Now, what I can use this to help showcase this better, but this is what a layer is, right? We see a certain number of neurons or nodes, much like a brain does, and you feed information to them, and eventually, based on, let's say, this particular one is extremely good at distinguishing things from left and right, or up and down and stuff like that, right? Like the one here, and then these become more specific, and over time they're built very, very specifically to ensure that you're able to capture the right sort of things from the data. So you convert your data, your raw data, into information. You give it context, you give it columns and rows and just much more to it, so that it makes more sense, right? So a single layer, right? So this here, ReLU layer, is essentially an activation layer. Now I encourage you guys to check out exactly what an activation layer is. To put simply, are you guys not able to see stuff? I don't see any errors on my end. If you guys have any problems coming up, please let me know in the chat. I see. So you guys aren't able to view anything besides just the first. Okay, I'm sorry about that. That's not right. Any improvements yet? No, it doesn't look like it. I'm sorry, guys. Just give me a moment here. Yeah, I'm having a look at my OBS. I think there's an error even on the. I'm sorry, guys. Just give me a second. Okay, now do you guys see something? I think it should have fixed itself. There should be a moving GIF thingy. Right. Okay. I think there's a little bit of a delay though, but there should be more movement up now. Right. So I'm hoping there's movement happening. There's a bit of a delay, guys. I'm sorry. It's okay. Perfect. Thank you, guys, and I'm really sorry. Still trying to get a hold of all this. But this is essentially what I meant when I said, it's essentially just mathematics being done very smartly. I hope this GIF helps. I hope it's visible, and I hope it makes slightly more sense about what essentially happens in a model, right? And thank you guys for for being active on the chat. But as you can see, it has some initial conditions with certain variables being defined beforehand. And after essentially the data, right? So what's happening, the flow you see here is over time. Okay, perfect. Thank you guys. Yeah, so as and when the model is being trained, you see that it's making use of and it's being altered according to these metrics. Now, once it reaches a certain level, let's say it crosses your your initial layers, it enters the trainer, and there these same exact variables are now altered depending on what the output was from these initial layers, right? And then this happens again. So the difference between you doing it just once and doing it again and again is essentially what distinguishes between a neural network and what is just you simply employing math to train to do some. Essentially, if you do simple math and if you do that math but you get influenced by it based on the output, that's what distinguishes between just doing simple math and you actually employing machine learning, right? So you are actually you have a feedback loop, right? Depending on what happens here, stuff gets changed back here, and this goes on in cycles for as long as you want it to go on for. So the epochs and things, that's what this distinguishes. So I hope this should be visible. I am currently, I think there's a slight delay, but I'm on the TensorFlow playground, and this is also available on that same doc. So if you guys are interested to sort of try this out with me, please feel free to do so. But here it's pretty it's shown very well essentially what happens in a model, right? So here we see your initial features, right? So now what exactly are we trying to get from this data? So here is the data, and the more neurons there are, essentially the more intricacies we can find. Now this isn't that, of course, it's not a direct correlation, right? There are more smaller niches to this, but that's one sort of way to look at it. And the final neurons are what sort of the output. Yeah, so depending on the impact of these neurons, the output is changed, and you need these neurons just to sort of showcase your output properly. So what I'm going to do is I'm going to train this model for for a few epochs, or maybe for a few hundred epochs, and we will essentially watch live a model being trained, right? So if I play this real quick, there we see on the right the distinguishes have been made, and we see the loss is decreased, the test loss is decreased. I can stop it now. It's about 500 epochs. So this is much faster than what one would get using the just a computer. But here we're able to sort of understand what just happened, right? So these initial layers told it to make some certain vague distinctions between the left and right and up and down, and then the next layer was able to make, as we see here, slightly stronger distinctions, which are angle lines and sort of stronger separations, to make a more defined or controlled environment within which we want to train and test our data. And these last two neurons, influenced by the weights and everything, took on certain shapes. So we see here, this looks almost like a cone, and this one has its own sort of separate distinctions. Combined gave us this. And here we see that the blues and the oranges have been very, very easily classified, right? And we can very comfortably distinguish between the two, right? Now this is pretty much exactly what happens in a machine learning model, right? Hidden layers and stuff like that is essentially just what we saw previously, just happening at a level where the influence of it is much more passive, right? It's much more subtle, and so there's no essential large need for us to influence them a lot. They're built and they're used up through the frameworks we use. So TensorFlow handles this on its own very well, and we can sort of, and if you guys want me to, and I think I'd like to do this anyways, but we can try out certain slightly more complicated more data, right? So we can increase the noise, and we'll see here all of a sudden this data isn't super clean, right? It becomes extremely difficult to distinguish the blues and the oranges and stuff like that. And this is a much more realistic sort of showcase of what happens to our data, right? And we saw how even these neurons and everything got influenced, as we can see here, depending on how much the noise was, what kind of intricacies were needed. On those bases, these neurons were also impacted. Now, if I were to train this model, it might take slightly longer, might have certain bigger flares, but there we are, right? Now it's able to isolate itself, be like, okay, this is more or less the blue and that's more or less the orange, but we see it's actually very incorrect in some places. This is clearly not blue, but it's still being marked because, well, within the given constraints, this is the best it can get, right? And this is a very, very good way to understand why building a model becomes complicated, right? Because technically speaking, I could employ this same exact topography to most data and get worthwhile output, right? But evidently not, right? Clearly we have problems. Now there are two ways to deal with this, and I personally enjoy the second one more. First way is you alter the topography itself, right? You find ways to get more intricacies. You make this more complicated, right? So you have more features you want to find. You have more neurons you want to involve. They have their own intricacies. More neurons here, and you allow the model to learn more subtle things within the data. We train it again, and well, it got to a decent accuracy, but here's the difference. Now the shape is not just a clear circle, and slowly, after about 350, 400 epochs, it's making much better distinctions. It clears out from here, goes in from there, goes in from there. We can stop. I think now is a good time. And this is a much better a much better way to figure out or understand where exactly our data lies. Not perfect, but much better, right? These points are very, very clearly filtered out. Some stuff can't because it's almost overlapping, but the stuff that can be is mostly almost filtered out, right? Of course, that one's not the best, but this is what I mean, right? This is one way to do it. Another way, and the second way is something like I said before, I much prefer, and I would highly recommend all of you make use of much more, is processing your data, right? Because figuring out the niches to extract very, very specific intricacies within a model it's something that takes decades of experience, and you still can very, very easily get it wrong, right? But being able to have power with your data is what can decide whether this can take you 700 epochs or maybe 200-300 epochs, right? Cleaning up this data, making use of it correctly, stuff like that. And so if you were to decrease the noise, this is essentially overkill. You have so many neurons doing this, right? It took it less than 100 epochs and it was extremely close, and it took it close to 200 and it's already made some very, very good distinctions. And this still takes a lot of processing power, right? It's by no means more efficient or any less efficient. It's just one way to do it, and this is, I think, a very good sort of way to understand how one thinks about building or dealing with a problem, right? So if you guys are interested, I would highly recommend you guys go back and check this out yourself. Open up this, and like they say, you can't break it. There's no way this can be broken, so go crazy, right? Try to understand what activation layers are. If you change these, what happens, right? What does this mean? The rate, if you want to classify, or there's also regression, so you can separate across this data. The rate at which learning rate, what does this mean, and how can these factors impact your final output, right? So yeah, so this was I'd say a simple glimpse into what happens in the background of you training a model, right, and how it sort of handles itself live. So I think if you guys have any questions, please feel free to put them in the chat, or if you guys want me to do something as well, we can do that together. But if not, I think I'll move on. There's a slight delay, so if I see something, I'll go back. But we can move on to the more interesting stuff for the day, which is the OpenAI Codex. Right now, honestly speaking, this was almost groundbreaking within the field of machine learning the moment it came out. Right, this is ridiculously powerful, and I would like to be able to show it to you. So the access to this is limited, right? Because it's in beta, it's still being built, stuff is still being pushed out, but it's extremely powerful even now. One thing that it does extremely brilliantly, and why I think eventually devs can become almost obsolete, is this natural language to Python. So within this comment, if I write something like take an input from the user, right, and return the square root of the number, right? Now I'm just asking it to do something fairly simple right now. If you tell this to a human, they'll know what to do, but this is a model. This has no idea, like this was not done before. And to prove this, uh, if you guys are interested, please feel free to drop in some prompts in the chat. I'll pick them up and I'll paste them into the playground, and we can see it live. That there is no games happening in the background. This is this sort of, it learns and figures stuff out on the fly. So I hit submit. It takes a second. And there we go. I now have functional code which will give me the power to get an input from the user. Yes, it's doing that very well. And it's printing out the square root of that number, and then it's calling the function that it built here. There you go. So you don't need a dev or even knowledge of of Python to get yourself functional Python code. And I think that's pretty absurd, honestly speaking, but that's one very, very powerful thing that came out recently, and I was lucky enough to have a chance to hop onto it and try it out. So I figured maybe show it to you guys, explore it together. But yeah, like I said, if you guys are interested in having me put in some prompts yourself, please let me know in the chat. Yeah, so I mean, there's a lot more that can be done with this as well. So you can have chat, Q&A. It can summarize for a second grader, make things simpler, make things more complicated, explain code, classify stuff. There's a whole lot that that this Codex is able to do. And recently, so there's an API available for it already. So it's pretty easy to employ this into your regular daily use and essentially make programming obsolete. But yeah, even complicated stuff. I think I remember asking it to build a model to, let's say, categorize cats and dogs, right? Submit. Well, I don't know if it took that submission correctly. Okay, so here we have it building a model. Here we go. So, and this is kind of where things start to sort of, I don't know if fall apart is the right term for it, but it built an entire machine learning model right in front of our eyes, right? And I can go ahead and explain this to you if need be. I think there's still more to it, by the way. I think it stopped a little prematurely, and I'm not sure why. I think the response length has to be altered, so that's my bad. But I think you get the point, right? This is an extremely powerful method to essentially create code out of nowhere. Now, what's interesting about this is that it's not an all-knowing, all-being kind of extremely powerful model. All it does extremely well is that it's able to manipulate and understand language. So what it's extremely good at understanding this part of things. And because it's able to understand that, everything else you can find on the internet, can't you? So you can single search on Google with the right terms, with the right things, and you have yourself a whole model available to you right here. And that's extremely powerful. And I think recently, if I remember correctly, some companies were hiring, it was, I think, prompt engineers, so people who can very smartly come up with this part of the thing, put that into this playground or their respective API, and just get back exactly what they want. It could be literal code, it could be a Q&A thing like a chatbot, it could standardize, it could summarize, it could fix grammar, text to command, English to French. Right? Let's try out English to French, why not? So what is your name? And we hit submit. There we go. There's the French for the term I just wrote. I'm not great at French, so if it's wrong, I'm sorry. But there you go, right? And this is a functional piece of piece of tech available to the internet. And yeah, so I just found it extremely interesting, and I thought I'll show it to you guys. We can go back to this later if you guys are interested, sort of to explore some more, or even later, even after the live's over, if you guys want. Feel free to reach out and we can sort of talk over this, have a look at how stuff is going. I hope that the live stream is being fine so far. I don't see any errors or anything popping up. If anything comes up, please let me know. It's kind of hard to tell for stuff from here, but yeah. So we can sort of move on now to slightly. This is just kind of like we'll just skim through all this. I won't spend too much time, understanding what's happening here. But what's TensorFlow right now? Now that we've sort of had a look at the interesting and the boring and the cool parts of machine learning, why TensorFlow, right? And what exactly is it? Well, the great thing about TensorFlow is that while there are numerous other frameworks out there, right, to learn and to train stuff, TensorFlow actually is built and it's what's it called, run heavily by the community, right? It's available on GitHub, so anybody can hop on there, give feedback, help them with the code, have some push requests, pull requests, and whatnot, and just make the whole sort of interface much better, even as just a dev, right? So even I could go ahead and if I have a breakthrough or something that I want to contribute to this, I can. So it's able to stay up to date with the needs of a dev because it's built by the devs, right? Completely free to use, open source, and it's just extremely powerful, right? So if you hop on to their official website, you can get your own some simple resources. So your first neural network to slightly more complex things, and you can sort of go over this. So feel free to hop onto the website and have a look at this yourself. I'd highly encourage starting off somewhere, have a look at the API, learn resources. They have a lot to offer. We can close that and move on. Next thing, this is the TensorFlow Hub. Now, this is kind of also kind of ridiculous, right? Because you have a way to call pre-trained models within TensorFlow, right? And we will sort of go over why this is so powerful and what this all means sort of towards the end. But it's just extremely powerful because you have BERT for NLP. This was built by Google with a lot of data, with a lot of professionals behind it to help train and learn and figure out what's the best way to do natural language processing, to understand and work with language. And this is available to us for free, completely free, by a single line of code, right? You can just import, you can import, upgrade, and you can just call a specific, model from the hub, and you have it. So TensorFlow Hub, highly encourage if you guys are, just trying to explore stuff. You don't really want to build it yourself because it's something simple, but you want to make use of it. I'd highly encourage you guys try out Hub, and there are a bunch of more websites as well that I'll be showing that do something very similar. But yes, this is also there on the ML resources link from before, so feel free to go back and have a look at it. Data search research.google.com. I think this explains itself fairly well, but it's Google's own sort of platform where you can search for data, right? And again, I think this explains itself, but being able to find worthwhile data is quite difficult, right? As you'll sort of learn, the moment you sort of enter the field, you will have brilliant ideas, but if you don't have the right resources to build it, even if you have the skill for it, it will not. It's very hard to build it. It's almost unrealistic to build it. So these resources that I'll be showing you for a little while kind of help bridge that gap very well, right? So again, you can have a look at the infection map. You can explore that on their own websites. You can go back. You can try something else that I just sort of showed. The first thing I saw with COVID-19 and whatnot. But close that for now. But yeah, so we have these resources, and I'd highly encourage you guys to check it out as well. Moving on to this, the Open Images Dataset v6 plus extensions. You can. I hope the stream's fine. I don't see any errors again. If something goes wrong, guys, please let me know. But this is, I think, one of the most powerful things I've come across in a while. And if you guys are looking to get more data, to get appropriate data, this is a brilliant place to be. Because right here, as you can see in front of yourself, this sort of gave me a test term with camel, and immediately I have a ridiculous amount of images of camels where they've also been sort of, it's very precisely also been labeled out and placed for me. So being able to train a model from this is extremely powerful, right? So you can get yourself just the label, just the image, and so on and so forth. There's a lot you can do with this, and we can also have a look at the amount of things they have. Okay, thank you, Justin. But they have a lot of things that you can sort of have a look over, right? So from a brown bear to a burrito, right? And it'll be able to provide you worthwhile images of all of it, right? And that's extremely powerful. From coffee cup, I don't know, man. It's just ridiculously powerful, right? And I would highly encourage that if you're interested in sort of just finding out and building your own data or even model, have a look at this website, have a look at the sort of description, how to download it. It's free to use. It's extremely powerful. I'd highly encourage you guys go ahead and check it out. Next one is called Papers with Code. These are open source papers that were used for research and everything that also have the code and the data as well. So, I mean, I don't know if I need to explain more since this is kind of in the theme for a while, but you get to experience essentially research being done within computer science firsthand alongside the code, the data, and so much more. So again, another brilliant platform to go on to find some data, to find yourself some extremely interesting, I would say, data sets from cityscapes, celeb faces. I don't even know what else, man. It's kind of absurd, right? Sentiment tree banks. So it's actually quite cool as well to figure out what someone's feeling. There's actually a tree being built for you, so you can sort of traverse through it and figure out what's happening. IMDb reviews, OpenAI Gym. It's actually kind of cool. But stuff like this, right? So another great platform to try out some very research heavy things. And have a look at them. Even potentially be able to read some papers. So there are literal papers available to you to go ahead and have a look at. Sort of look at the results and whatnot. So again, extremely powerful. Highly recommend it. Kaggle.com. I mentioned this before, and this is exactly where I got the data from for my wacky little machine learning model, which I will need to reconnect. But it essentially has anybody on the internet, me, you, anybody can just hop on here. The code we write, the things we build, we can just place them on here for the world to see, right? Anybody can go ahead and make use of the stuff we write, of the sets we build, and just so you want something to figure out what flower you're looking at. That's right there for you, right? So Doom Animal Crossing, how to look at a bunch of things along the same lines, pretty cool. But stuff like that, right? So you have stuff from memes to even competitions. Is actually quite cool. I entered a hackathon a while ago that actually required us to hop onto their Kaggle competition, right? So you can find hackathons win a lot of money. I will tell you though that this is you have to be extremely good to actually have a chance at these, because these are quite tough. But if you're interested, I would highly encourage just hop onto them, have a look at people's work, see what they're doing. Even if you just have to copy their code, it's a brilliant place to start, right? Because the people here are building something to win, and we get to see it firsthand. Extremely useful, extremely powerful. Model Zoo, you can discover, I think it explains itself fairly well, discover open source deep learning code and pre-trained models. Same as the previous few. These guys, this stuff has already been built by other people and also trained, so you can make use of their work and amplify what you have already, right? So extremely powerful. Again, I highly encourage you guys to check it out. Deep AI, this I kind of wanted to try this out myself, but it's a little iffy sometimes, but it's extremely powerful. But add color to black and white images. So basically, if you have like pretty wacky and interesting ideas and stuff, there's a good chance it ends up here, right? From being able to exaggerate textures to figure out positive or negative, to shorten a text. So one day, if you don't want to read the entirety of your text, hop on here, summarize it, make that stuff short. It'll take you half the time, get that information in as well. So a lot of extremely cool pre-built, extremely ready, like if you hop onto one, I can upload an image right now. Hopefully this is one of them. Right, maybe not, but I like to just sort of quickly show you maybe something very simple. So as you can see, try it. So you can just open up one, upload your image to it, it'll colorize it and give you worthwhile output. So stuff like this, extremely useful, extremely powerful again. So yeah, I'd say just go back and have a look. Even if you want integrate this into your websites as well with some APIs, I mean, it can do a lot within the few things that it has to offer. So yeah, also has jobs apparently. That's nice. But here you go, right? Yeah. So moving on, another marketplace for AI models. same as before, except these ones I think also have paid options, and these are much more professionally built. But a lot of them are free, and I encourage you also to have a look at them, so you don't sort of remake some stuff that's already been built by somebody else professionally. So palm detector, stuff like that. You want to sign language and stuff, extremely useful stuff that you can use at hackathons as well. Hop on here, have a look at what to do to make use of it, and it gives you some instructions, get model, output, test stuff. You can do plenty with it, right? So extremely good there as well. Another model hub, same as before, similar stuff. Make use of them in your daily sort of projects. This is pretty cool. So this is called Fast AI. Yeah, it's actually extremely powerful. It's quite accurate and it's quite quick. So yeah, I'd say go back and try it out if you want to. I'd encourage it highly. So moving on to Fast AI. So this is another framework, much like TensorFlow, where you can essentially you can learn their entire essentially like I think this is 1 hour each, so 8 hours worth of professional content available for free to watch and learn, right? And even has well, images is the whole thing, but notebook servers. So you hop onto Colab and you can get yourself like every chapter, the code of it, the work of it, the text of it, extremely well done. So if you're looking to sort of learn machine learning from scratch, this is a brilliant place to start. It teaches you the basics, the math, the stats. So have a look at this as well. All right, so I think we've been live for, how long have we been live? About 40 minutes. That's longer than I thought. I'm sorry about that, guys. But now we'll be getting into the actual code. So this is going to be technical. We'll be diving a little more deep into the intricacies of what actually syntax means and how to essentially go from just having some data to actually making worthwhile use of it. So I kind of want to start off with, so this will be, like I said, it'll be dense. So I like you to pay slightly more attention now, because it takes a while to get used to it. It took me a long while to get used to it. So but yeah, one thing I recommend is that if you have a doubt, right, like if you're unsure of what, let's say, dropout does, right, it's a TF Keras layers dropout, right, I would highly encourage that you look it up, right? And I know this sounds like I'm being mean, but honestly speaking, a lot of the times, and even I'm guilty of this, we don't look this stuff up, right? But this exact term has been looked up. Yes, I am using Keras. But this exact term has been looked up, and this exact sort of problem has been encountered multiple times. So just looking up what dropout does on Google, this is looking up TensorFlow dropout. That's all you got to do, and it will tell you exactly what's happening in the background, right? So, and within machine learning, within this field of machine learning, it's very important that we're comfortable looking up stuff like this, right? Because learning the syntax is not something that you will need to do very often within machine learning, right? It's just one sort of side part of this, purely because the data, pre-processing it, making sure that it's the right kind, it's handled well, it's manipulated, it's altered, it's the right form, is a lot that goes into it. That's where most problems occur, because the topography can be very similar. Same thing that I showed before. This can be used for multiple ways. If your noise is less, it takes less time. If your noise is more, it takes more time. Remember that, right? And being able to sort of find these distinctions is what essentially what separates somebody from being completely lost with what to do and actually getting a worthwhile model being built. So this is a quick start for beginners. This is available on the website of TensorFlow. So this is not done by me or anything, but I thought it's a decent place to start, right? So we can just sort of slowly go over these code blocks and have a look what's happening, right? So MNIST is a data set that actually, if I remember correctly, yeah, so it's handwritten digits. So it's just handwriting. It's just numbers 1 to 9 written by somebody with a pen, and pictures have been taken of it of extremely high res, and we'll be using that to build a very simple model that can learn how to recognize handwritten numbers. That's kind of the point of it, and it's quite cool. So now that we have the MNIST data set, everything in place, we can just load the data, sort of separate it to convert them from integers to floating point numbers. Here we're building a sequential model. So a sequential model is nothing but a sequence of layers. So this right here is a sequential model, right? It's a sequence of layers. That's what it means. So now, once you think about it, it's actually extremely simple. Flatten. The point of flatten is that initially, once you input some images, right, they could be multiple dimensions in terms of how they're saved. Flatten ensures that all these dimensions are flattened down and they're sort of maintained throughout the entirety of the model. So here we ensure that the input shape is this, right? So this particular layer, so think of it like this layer, or actually I haven't said this layer, ensures that the images are all the same type. This one, again, activation, right? So activation ReLU, an activation function, the purpose of it, and we'll see it here as well, right? Different kinds of activations, so ReLU is here as well. What does this mean, right? Now, again, this is something I would highly encourage you guys to look up because it's quite dense, right? And if I start to talk about this more and more, it'll take us days, right? So to keep things just as an introduction, I'd encourage you to have a look at this online. But the point of this is it has to understand where to begin from, right? What to expect. Well, here we're looking at a fairly, you know, our data is not straightforward. It has, you know, 0, 1, or 2, or 3. It has a bunch of ways. So ReLU ensures that we stay within zeros and ones in terms of our output, in terms of our accuracy. We don't jump out of ones. We don't hit 2s and 3s, right? It ensures that we stay within a certain range. There's much more to it than this, and I don't think I can do justice to activation, the function. So I'd highly encourage you guys go ahead and check it out online. ReLU is one of them. I think there are, as we can see here, TANH, sigmoid. Sigmoid essentially squishes your data from, you know, being same as before, being from 0 to let's say 150. It makes it from 0 to 1. It's able to squish it extremely well. So different activation functions have different purposes. What they mean, what's their purpose? Like I said, quite dense. I'd encourage you guys go back and have a look at it later. 128, I think this is the node number. So how many of these neurons you're actually making use of, or actually the size of them. So it's again a little more different than just the straight number, but that's the essence of it. Dropout. So dropout is quite interesting because what it's doing is at random, every time you run an epoch, right? So we're doing something's happening. At random, it'll take, let's say, this neuron and just remove the output from it, disregard it, right? And the purpose of this is to ensure that things stay changing. You will never achieve 100% accuracy because at that point you've learned the data. You actually haven't learned how to distinguish between stuff. You've just remembered stuff, right? You haven't learned anything. So this ensures that you know, you never actually hit 100% accuracy. You stay underneath that and you keep messing up. You make those mistakes, but the point of it is to so that you don't overfit. Overfitting, like I said before, means that you've remembered the data and actually haven't learned from it. So dropout is pretty interesting. It's at random, it just drops a node, right? And it sounds like a very, very poor way to handle stuff, but that's just kind of how stuff works around here. And the last layer is a small layer called the dense layer, and same as this. So a dense layer, like I said before, densely packed nodes. So a small dense layer, the point of it is just to provide us the output. So here we have just 3 or 2 neurons, just to make sure that our output is, you know, is simple and is maintained. So there you go. And within literally just these many lines, a whole model is built, right? So that's my point when I say that building a model is actually the easy part of it. Processing it, making sure that things remain the right way, right? They aren't sort of blowing out of proportion, or they're actually worthwhile enough to be trained upon consistently. Your data becomes information within a worthwhile amount of time. That's what takes 90% of the brain power of a data scientist, right? Here we just sort of figured out, right? So again, like I said before, this wasn't built by me, so there's a certain way they store their predictions variable. Softmax converts them to probabilities, and here is just sort of what's it called? Right, so they built the model here. Yeah, so the structure of it was built here. Here they're sort of ensuring that the output is worthwhile and it's evaluated, it's fitted and evaluated, and you can have a look at it here. So I won't go through all of it because it takes some time, but the point of it is within about, let's say, like literally this block of code and some smaller chunks here, and then maybe this one and this one, perhaps even this one, but this one isn't always required. you're able to build a whole model that's able to understand handwriting, right? And that's quite powerful if you ask me, right? And now we look at a slightly more, what's it called, dense problem, which is not as simple as, just build a few lines and you're done, because the data here is extremely noisy. It's not clean, and it takes quite a while to make it to clean it up. So if you guys are on here while using the platform Collab, I think this is a good time to sort of talk about it. But you can run essentially most Python code on here, I think all of it in fact, including TensorFlow and stuff. And so instead of you having to rely on your computer as resources, just hop onto this platform and just go up to file and just create yourself a new notebook and start programming, right? You will be employing Google's resources, not your own. So that allows you to make mistakes, and that's the best part about this, in my opinion. You can make mistakes, right? If you mess up, it will not mean that you can't use your PC for a bunch of hours only to have the wrong output, right? It's powerful, it's quick, and it will not burn your resources. So if you're trying stuff out, if you're new to machine learning, and if you just want to throw some code around, copy paste some stuff from here there, I highly encourage you to try out Collab, right? Free to use, extremely powerful, and just an all-around brilliant platform, in my opinion. It won a bunch of awards a few years ago, back when it was actually released. So yeah, I think now I can sort of go over. So it's quite long, so I don't think I'll be spending a lot of time going every single line here, but just to prove that I'm not messing around, this is actually memes from two separate games. Meme from Doom and a meme from Animal Crossing, right? And the reason why I chose something so wacky was so that we aren't stuck with just making use of or understanding cats and dogs, right? Or like horses and humans. That's been done multiple times, right? The point of this was to learn something new, to figure out that a model can be built from literally comprehending language. Back when we saw from OpenAI Codex all the way down to distinguishing memes, right? There's a whole spectrum to this, and we were able to sort of get a small glimpse at the entirety of it. So simple, we're importing. So with Keras, you have to import sort of certain the things that you'll be employing. It helps sort of make sure that you aren't, because if you import the entire thing, it's actually quite inefficient. So you want to if you use something, I recommend you go back and you import it separately here. One thing that I'll tell you that we are making use of something called transfer learning. This is a very powerful concept within machine learning, where you don't have to actually sit down and train a whole model from scratch, right? You kind of just go ahead and make use of pre-trained stuff, so that your actual work becomes from training a model for multiple hours to a few minutes, right? And I think that's a very powerful asset to have in your arsenal. So your simple imports, so these libraries help you visualize and do some simple math, PIL as well. To I think this is for imaging, and certain things that we are importing from Keras and from TensorFlow. So like I said before, we're using Kaggle. So throughout this, you will have to go back to Kaggle and get like a JSON file, have that uploaded here. Small stuff that's required to authenticate you, give it the right permissions. But the whole point of this is just to get the data set within here, so you can actually get the data set here. I'm not doing it live because it takes some time, and it requires me to show some information that I don't think I should on a live. But if you guys want me to, I would be more than happy to go ahead and make a whole video about how this was sort of built from scratch. I think it's quite interesting, and if you guys are interested, please let me know afterwards via Discord or any other means. Yeah, we unzip it. This shows up some images. It inflates itself. Can go over that. Okay, so we have a directory from where we actually store our data. We predetermine our batch sizes and our image height and width. So if you want it to be a square or this particular size, simple stuff. Here, we are building our initial training data set. So this is the directory, the split. So how much will you check it from? How much is the actual data? It's the training subset. Seed 100 just makes it more random. That's a kind of, the seed is a term within a library that decides how random something will be. So 100 just means it'll be quite random. Image size, we have the height and width, and with the batch size mentioned before. Simple as that. So here it tells us it found nearly 1.6K files that have 2 classes, right? So the classes, I think we go down and have a look, Animal Crossing and Doom. Same thing here, but this one is to validate. Very almost same stuff going on in both places. But so the subset here, right? This particular I can get to that in just a moment for the Discord. But the subset here, right? This will distinguish essentially how much of, so this is done extremely smartly by TensorFlow. So me just entering the term training tells it that it has to pick up the larger chunk of files for training, and me using the subset or the term validation, because like I said, the look and feel of it is quite similar, right? But just the term validation here tells it has to use the smaller chunk of files to validate. And this is built extremely smartly by TensorFlow. This is the class name, so we have a look. Animal Crossing and Doom. We have a very binary sort of problem here, 0 or 1. Animal Crossing or Doom, cat or dog. A fairly straightforward distinguish how you distinguish between two things. Animal Crossing, Doom, like I said, these are memes, right? So cardinality just sort of talks about how much of something there is within a particular variable. So we have 70 training batches, 16 validation batches, and 4 test batches. Excuse me. This stuff gets a little more complicated and interesting, but auto-tune essentially, so this is just me, you just, there's no reason to do this, but I felt this was a cool thing. It's kind of new within TensorFlow, but what happens is that when you sort of when you build yourself something like a batch like this, right, it's very, very inefficient to go back and keep using it for every single epoch, right? Every time you train it. The longer the icon of sin is honored, the stronger it will become. I'm not sure if that's a meme from the game or a different thing, but fair enough, man. But yeah, going back to this, using auto-tune. So the syntax of this, like I said, you just have to prefetch buffer size is equal to auto-tune for all 3 of your so test, validation, and train, and it just ensures that the flow of your data is clean and efficient, right? It's quite early in terms of its stages of being deployed, so it's kind of experimental. That's why it's not seen very often being used, but it's quite powerful. So I'd recommend, if you guys want to try stuff out, like I said, the perfect place to try it out is on Collab. Just hop on, try some things. If it breaks, it breaks. You won't lose much except some time, which is kind of anyways being spent. Doom memes indeed. So next thing is augmentation. So this is my point, right? We are nearly halfway there, and all we're doing right now is just ensuring that we have the right data, that it looks the right way, it's the right format, it's the right size, it's saved efficiently, it's batches, this, that. 90%. You kind of shoot a hole on the surface of the Mars. Doom would disagree, but here we are. So would Elon Musk actually, but but yeah, so we spent this much time just augmenting our, just ensuring that it's the right size, the right batches, and now we're just augmenting it. The point of it is just to flip it randomly and rotate it randomly, right? We're literally spending time just to ensure that our images look worse, just so that we can diversify our data, right? And like I said before, a lot of machine learning, a lot of data science just comes down to how well can you manage this, right? The first big chunk, because the actual building process is actually being done for us quite well because of transfer learning. This is handling everything quite well for us. So a lot of time is being spent in just us. Again, a big chunk of it is just stuff like this, right? I'll skip over this. This is people model. I'll go back and continue. But a lot of this is just us ensuring that our data looks the right way. And that's because this was quite noisy, right? It had problems. It was not inherently augmented. It was not inherently the right size. So what happened here with the noise, it was maybe somewhere there. So it required this to be decently complex, yes, but more importantly, look at this, right? It had problems. It had things that had to be managed, right? So that's the approach I took of being able to handle the data. So here we're just looking at some of the augmentation. So it flips randomly, has some random rotations, stuff like that. Or it's flipped and rotated a bunch of places. So, stuff like that's happening. We're rescaling it as well. Similar stuff right now. Preprocessing input, this is kind of where we see a glimpse of transfer learning. MobileNet V2 is a pre-trained machine learning model built by TensorFlow. I'm sorry, built using TensorFlow and is available to you on the internet. So instead of me sitting here and spending hours and hours trying to figure out, what exact topography, what exact set of nodes and layers works the best to train this model, all I'm going to do is I'm going to use a pre-trained model and just ask it to, hey, I have some data. Can you please just train it for me? That's all I'm going to say to it, and it's going to do it for me. And that's one more extremely powerful thing about machine learning. Handling your own workload, right, is almost a superpower out here. So this is just another sort of rescaling augmentation thing. So this right here is actually a file that I can also have sent to you guys. I'm sorry, this is I missed this one, but it's a zip file that contains the weights of this particular model, MobileNet V2. What exactly are weights? Well, this can tell us. The weight is how much impact every single node has on the next node, or the next layer for that matter. Excuse me. So these weights over time are changed, altered, depending on the output, the input, the feedback loop that I mentioned in the beginning. This bad boy handles it for us, right? Having it pre-built for us, we just download it and we just call it here. We have the weights ready. We're like, hey man, this is how you would train before. Just do it again. Just do it better. Just do it on top of my data, right? We give it some initial shapes and stuff, and we have ourselves a base model ready. That base model is just MobileNet V2 with some simple input stuff. Include top, that's again a specific thing because we're using transfer learning. I would highly encourage you, if you're interested in learning more about exactly what's happening in the background, have a look at the transfer learning guide available on Keras, available on TensorFlow. Fairly simple stuff. You make a batch, so you make it. So why are we making it? Why is it false, right? Well, we freeze the model to ensure that no info is altered or destroyed. So we have a model ready with our base model, right? We have this part, this stuff ready before we train anything, right? We have a base ready in the form of this the model that I imported before. We tell it, okay, hey, it's ready, it's there. Don't do anything to it. Leave it there to ensure that everything that it knows naturally stays, right? It is still a very, very powerful model. Keep it as it is, right? It's been trained on millions of things. Good. Keep it that way, right? Don't start training it from scratch, right? Don't just look at this, oh, looks so cool, just train it again. Don't do that, right? Don't train it. Now, this is a summary. This is what mobile, the thing we import looks like. It has a lot going on, right? So this is my point, right? Instead of me sitting here and building this from scratch, messing up, having so many mistakes in my model, I can just import their work and make use of it efficiently. We move on from this. So a global average layer. This just, this is again slightly complex, but it'll reduce the size of all spatial dimensions. So it will essentially have a look at everything you have to offer within your data, within everything you've built. So the last one here is 1280 on the basis of our model. So you see here right now it has 4 features is what they're called. 4 different ways we can go about exploring it. We simple it down to just 2. 16. So this number it figured out on the basis of some math that's been done passively. 1280. This one is maintained. So this is almost a great way to almost understand how larger models and a lot of data is. It ensures that all of it, if not most of it, if not all of it, follows sort of the same flow, right? So a global average layer helps us accomplish that. Now we make a very simple prediction layer, a single dense layer to get appropriate predictions, like we saw back here. This is normally 2, so it's a simple baby boy, a 2 neuron layer just to ensure that we get the right data. This actually we are making use of. So I actually wrote all this, so that's why it's fine if I read it out, right? But TensorFlow has its own transfer learning stuff that we see right here. So I picked up a very, very interesting and important piece of code from here. I'm not sure if I can find it. It was actually quite down there. I'm not sure where, but it looks kind of stupid, right? Because we have x, a function that we initially defined, and we just redefine and redefine and redefine, and this looks pretty stupid, right? Like, why would somebody want to do this to their data or to their values? Well, what this does is actually chain it together, right? So it's a tactic that TensorFlow themselves, Keras actually, and the entire framework uses very, very efficiently, where you chain together augmentation, pre-processing, having a look at our base model, at the global average being involved, and the dropout, the thing I said before, where you randomly take a certain node, or you take a certain layer and you disregard its output. All this being chained together from a single variable x. So more details, again, I can't do justice to it in this time frame, so have a look at transfer learning. Very, very interesting, very, very important area of machine learning. And binary cross entropy, because, well, binary, like I said before, we are 0 and 1. We 0 being, let's say, Doom, 1 being Animal Crossing. We just kind of want to find which one works the best. So this sort of helps us accomplish that. And a loss model. So where's loss, right? Not the meme loss, actually loss function, loss in general, actually. So if you go back and have a look at this, we have training loss. So how confused or lost is our model at this particular stage, right? That's what loss tells us. So within sort of distinguishing, oh, is it 0 or 1, right? Where is it right now? So as you train your model, training loss gets significantly smaller and keeps getting smaller over time. This becoming too small is also a problem. It means that your model again has overfitted. It'll know exactly what's happening next, and it shouldn't. It should have to process, think, be slightly inaccurate, right? That's kind of how thinking and learning works. So understanding loss is essentially that, right? 0 or 1, and the loss method helps us compare what is it 0 or is it 1, right? So the lower it is, the more sort of comfortable our model is making a prediction, and the higher it is, the more uncertain our model is. And whoops, it's a pretty important. All these things are quite actually important within machine learning. So I recommend you guys sort of go back and explore these things more. But you know, and I think at the end, I think you'll all understand something that, oh, whoops, connect. So because I'm not really doing anything, I'm just sort of going over it, keeps doing that. That's okay. So we have ourselves a model summary condensed together, and we see this is so we see no real, you know, stuff going on here. This is just for simple input output. A lot going on here, and the big chunk of it was just called through transfer learning, and all I need to do now is just make sure that it trains efficiently. So we have 20 epochs. We have an initial model, so we just try and find out, hey, okay, how much do you know from being, what's it called, at the stage you are right now? About 47% accurate, and quite uncertain more often than not. Right, fair enough. We can, it says that again right here. We build ourselves, so model.fit essentially fits everything into place. So initial epochs that we mentioned here, training dataset we mentioned before, validation data again mentioned before, and we run it. And so all that's happening here is training. This is a model being trained, right? It took about 36 seconds per epoch. So one epoch is one iteration. So one chain, right? It went through once and then twice and then thrice. So again, this is happening at the speed of light essentially, but happening in a much more sort of humane time frame. We see it takes about 30 seconds to a minute, depending on your device and everything. And this is again a very, very interesting, a very good thing about the platform is 30 seconds per epoch is actually quite strong, right? Given you saw how much is going on by looking at our summary, there's a lot going on, a lot being used, and it's handling that much in about 30 seconds each. 20 epochs took it about, I think, how much time? I think have a look at the output. Apparently not. Well, let's do the math. Took it about 10 minutes, maybe a little more than that, to get us our worthwhile output, and was 87% almost accurate. So my old plan was to show this happening live to you guys, but it takes a long time, and to sort of go through all of it. Sometimes it takes longer than needed, so I thought we'll keep it simple and just sort of walk over the output. But yeah, within about 10 minutes, you have a working functional model that is able to distinguish between, and you saw a very, very tiny chunk of all this was actually us building the model. A lot of it was us actually making sure our data is actually, you know, the right size, the right format, the right dimensions, so much more to it, because it was noisy. So we can sort of go slightly farther ahead. We already went over this, and there we go. So TensorFlow allows us to have to keep track of our accuracy over time. So we can just go down and have a look, and here we are. We see through a graph our model becoming smarter and smarter. So validation and training and stuff. So more intricacies, essentially, you know, on some things it was smarter than others. It had some drops. So the dense layer, it's very evident here, right? Because how did it all of a sudden just get inaccurate? Well, there's a good chance that we disregarded something a very accurate node, and that dropped the accuracy, but came right back up the next time because we maybe pulled it back, or it just sort of caught on its own. So if we went on further, maybe we hit 90%, and you know, much more than that, but we keep it a reasonable time, a reasonable amount, and we have a working functional model that's able to predict memes, right? So now this is done, our model is ready. You have just built yourself a whole model, right? Within barely any proper work being done with the syntax, with this and that, because most of it's online, and the other half is just within TensorFlow itself. So we sort of come back here, we applied a sigmoid because we return logit. So this is a certain way you return your function. Again, more specific thing, kind of hard to get into just yet. But a sigmoid, like I said before, squeezes your data, I'm sorry, your output within zeros and ones. And well, these are again some small stuff being done, but this is what's useful to us, right? The prediction and the label. So 0 being, I think, Animal Crossing, and 1 being Doom. So it predicted this to be Animal Crossing. That looks like an Animal Crossing meme. That's a Doom meme. Another Doom meme. Doom, Animal Crossing, Doom, 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 Doom. And we see that actually the first one was in fact Animal Crossing, second one was Doom, so on and so forth. So we can compare right here how accurate our data is, and it made a mistake here because it predicted this one to be Animal Crossing, but it was actually a Doom meme, right? Stuff like this, like I said, because it's not 100% accurate, it's about 80, I think 87, 88%. And we see that sort of in effect here, but there you go. Now it was able to accurately predict between two memes, between the memes of two games, right? You were able to build yourself a model to recognize memes, right? That's the power of machine learning. It's from stuff like this to being able to write literal code from a command, from English, right? And that sort of absurdly powerful, absurdly huge range is what makes this field so difficult to get into, right? Where do you begin, right? Because that one, the OpenAI thing handles language very well, right? This is able to handle language extremely well, and here we have images being handled very well. So when you get down to it, understanding how to manipulate and make use of data, right? The right kind, ensuring the noise is filtered out, ensuring that your topology is more or less maintained. Those simple understand, and the stats and maths behind it is just takes you 90% of the way there. The next thing that you have to do is sort of the 10% is where you have to understand the syntax required to actually get this working, right? To understand what this means, to understand what these small things mean, right? So the entry into machine learning is not that difficult. Unless you want it to be, if you want to hop into the most complex sort of challenges, by all means, right? But the entry, like we saw right here in the beginner one, a single block of code is all there was that was handling and building the entirety of what you see in front of yourself. So the entry is very, very straightforward. It just needs you to be comfortable with not knowing something, right? You have to be comfortable with having bad data, with having no proper information. Providing it that information, being able to process that data takes you 90% there. And everything after that, it's either there on the internet for you using transfer learning, or takes about 5-6 lines to build. So yeah, what I suggest is you guys also hop on to some platforms from here, pick up a single piece of data from these websites, have a look at these random resources, copy paste some code. It's fine if it's wrong. It's fine if you have no idea what's going on. Just look it up. If you just copy paste, a certain part of it, just copy paste what the hell this means, right? And it will give you worthwhile information. And that's a brilliant place to start. As vague and as scary as it may seem initially, because it's kind of blind, it's an extremely powerful place to be in. So I think the last thing I'll show off here within this model is what it got. I think the least accurate, if I remember correctly. Yeah, so the most difficult for the model. So it thought this was Doom, or this was Doom, where it was Animal Crossing. This is Animal Crossing. It said Doom pretty clearly, so that's not, this is quite poor by our model. And some stuff happening here. In some cases we had crossovers, right? I think like here, for example, you have to read like the text and you think it's Doom here, but then it has Drake there. I don't know what that helps, right? So stuff like that happens. So again, our data was extremely noisy, hence the low accuracy, right? And yeah, so this stuff was hard for it to find, and that's perfectly fine. We can go back and we can retrain it, improve it. I think the last thing I wanted to show, which was in my opinion a very, very strong thing again of Collab, is that I can very, very comfortably save my model into a single H5 file. H5 is a extension used by TensorFlow fairly often to call and make use of its own models. So one line of code and it will create a model.h5 file for me right here, download it, and I can deploy it to the internet. I can save it offline on my device. It's like a 10 MB file, which contains a lot of information. It's the entirety of your model, right? And maybe at a different point in time, I can show how to deploy a model as well. I've done that before as well, and this is a great place to start. But yeah, I think that covers most of what sort of what it takes to find the right data and to build yourself a machine learning model, even one that is able to find and distinguish between memes of all things. Yeah, so if you guys have any questions, any comments, any concerns, anything, please feel free to let me know on the chat. How long was this live for? About 1 hour 15. Okay, slightly longer than I anticipated. I was hoping around an hour, but that's okay. I hope I wasn't too boring, and I hope you guys were able to learn a few things. If you want me to, I can go back and have mess around with this stuff of OpenAI, or give you guys some more details later on. So DM me on Discord if you're interested for anything like that. Yeah, I think that covers everything I have for this workshop. If you guys have any questions, like I said before, please feel free to DM me on Discord or put them in the chat right now. Yeah, I hope you guys had a great time. And it's currently actually 1 a.m. here. I'm in Dubai and it's 1 a.m. and I'm kind of tired. But I hope you guys had a great time, great afternoon. I hope you're all safe and doing well. Yes, it absolutely is. So you generally want to use something called well, actually I could maybe show it to you. It takes a while to open up, but Anaconda or Spider, SPYDER, is the name of the IDE. But if you're working offline, I would highly recommend Spider, SPYDER. Like I said, I can try opening it up. It might take a little while, but it's a very, very powerful IDE. So you do not need to write on Collab or any online platforms, right? This is useful because anybody, regardless of what device you have, can make use of this platform and train their own model. But feel free to use any IDE that can import and deal with TensorFlow and Keras or FastAI or these larger frameworks, right? So that could literally be the default text editor that comes with Python called idle. Could be all the way up to VS Code and whatnot. Yeah, of course, man, of course. I was extremely hyped about it too, because this model was actually kind of a pain to build because it's memes, right? How do you find, because I mean everything was so boring and it was already done before. So I was like, let's try to make things a little more interesting. And I sincerely hope that it was. If it wasn't, if you guys think there are any concerns or any feedback, I'd be happy to listen to it. Please hit me up on Discord, and I'll make sure that I employ that next time whenever I have the privilege of being able to host a workshop for the club. Excuse me. My voice is going away as well slowly. Yeah, I think, oh, there we go. So I can show you Spider right now. I have some random stuff on there, but I really hope it doesn't break the stream now. It'll be sad. Just a moment. So I'm gonna just quickly show my initial screen, and you guys can have a look at the offline thing. So I hope stream's doing all right. Hasn't broken or anything just yet. But yeah, so if you guys are able to look at look at my screen, I'm trying to show you guys the spider framework. I think it should be working fine. Yeah. So this is what I personally use to code offline when I'm trying to build something offline. I'd highly recommend it. It's really powerful, really useful. Yeah, it's pretty cool stuff, honestly. Should switch over. There we go. Okay. Well, any other questions, concerns, or anything? Thank you, guys. Thanks a lot for being here. First ever workshops. I'm sorry it was messier. If you have any feedback or any inputs, I'd love to hear them. But yeah, have a great day, and I hope to see you guys on campus very soon. Have fun. Take care. Oh.